Good morning, everyone, or good afternoon, however you are waking up today. This is physics, actually, the physics online lesson for today. Today is Wednesday, March 18th. Wow. Anyway, wanted to clear up a few things. I'm Mr. Finn, for those of you who are just getting online. Clear up a couple things from yesterday's podcast or video cast. There was a question I had through the email about the speed of the electrons in the circuit, which was yesterday's lesson. One clarification needs to be made. That speed, 1 meter of length at 0.01 centimeters per second, is for DC circuits only. So what's a DC circuit? A DC circuit might be something like this. You've got a battery system with some wires. They go to a bulb like we did in class. Comes back to the battery system. That's a direct current system. One battery or several batteries works as a direct current, which means that the current or the flow of charge is steady or even throughout. Okay, so what's that different than? That's different than an AC circuit, which is something that you might plug into the wall. Something you plug into the wall, the outlet might be an alternating current system, in which case somewhere on the other end of that line is a generator, which is going around and around and around and creating electric charge by a process we're going to talk about in the future. But long story short, if you have an AC system, so something that plugs into the wall, we are talking about something that oscillates electrons back and forth. Those electrons never really migrate anywhere. So when you turn on the lights, the energy from the light bulb is actually the electrons in the light bulb filament itself. They just jiggle back and forth with no particular direction. So it's important that we clarify that from yesterday's lesson. Thank you very much for your questions. I really do appreciate it. A couple other things of note. You need to check the Google Doc for Google Meets and times. So periods 1, 2, 3, and 4 have different Google Meet times. Those will be listed on the Google Doc with the specific days and times. If you have a question that you don't want to send by email, you just want to check in, by all means, you can log in and check that for the Google Meet time. So again, those are on the Google Doc. Check the Google Classroom if you're not already on the doc, or if you're on the doc, just go right to the doc itself. And it'll be your hour, your time, and your day to check in with me. Okay, other things. Thank you so much for your survey responses on COVID-19 outbreak. Not trying to make light of it, just trying to get a sense of where you're at, maybe have a little fun with it. Hopefully no one's panicking out there. We're supposed to be scheduled to get back into school on April 5th. Whether or not that goes over, whether or not that goes under, remains to be seen. It probably depends on how well we're able to social distance from each other and maybe try to drive that infection rate down. If you're interested in those results, well over 2/3 of you took the over, which means we would not be back in class on April 5th. And if that were the case, no problem, guys. I've got a few things working with my science colleagues. We're going to get you guys squared away, maybe get some labs done. Definitely touch base with you every day via the video podcast or video cast that we're doing now. Okay. Today, let's talk about this thing. What is this, you say? What is this? This is a piece of wire with 2 clips on it, always known as an alligator clip. Now, what is an alligator clip? Well, some of you might say, because it's wire, it's a conductor. It allows charge move from this part to this part freely through the wire. So long wires or short wires can allow charge in the form of charge energy to pass through those wires from one end to the other. Obviously, they're made of metal inside this plastic covering so that the charge energy can flow through the conductor, the metal, and then not be interfered with from the outside. So that's why the wire covering. But what also this is a small piece of resistance. Everything has resistance. What is resistance? That's just things that get in the way of charge flow. So if I was to send charge from point A to point B, something that resists the charge flow from point A to point B might make the flow rate less. So what are we talking about in terms of flow rate? I have a little demonstration. This, my friends, is an ammeter or a voltmeter. It's actually a multimeter, but I'm going to use it as an ammeter today. And an ammeter is something that collects information about the flow of electron energy in the form of amps. We know what amps are. If you go to your electrical panel and you flip open the cabinet, you'll see that there's little either fuses or breakers. They might be labeled 15 amps or 20 amps, or even 50 amps or 30 amps. This is what allows electron energy to flow through the system. So I'm going to just flip this to the ammeter setting right there. The first right there is ammeter setting. And that's going to tell me what are the amps or the flow of coulombs per second through a certain circuit. So what I'm going to do is I'm going to hook up this battery pack to this bulb and then back through the ammeter and back to the bulb again. I'm making one complete circuit. And I'll let you guys look at this in just a minute. But as I do this with 3 batteries, okay, you can see that my light bulb is lit. Got a light on there, so it's got a complete circuit. And you can also see that my reading is, I don't know if you can see that, I'm reading 0.219, 0.222, between 0.219 and 0.222 amps. So that means 0.22 coulombs per second are flowing in the circuit. Okay, so let me just pause and give you a little look at this. Okay, so right now you guys can see that we're getting 0.22 amps in the circuit. Again, right here, coming out through there, and that little white line goes to the negative of this ammeter here, which goes to my ammeter, out through the positive, which is this red cable, through the bulb, and then back through the battery again. So you can see we're getting 0.225 or 0.22, somewhere in that range. So what I'm going to do now is I'm just going to disconnect for a second, and I'm going to add 2 more of these wires, 2 in succession. So I'm going to hook them together. Hook one on here. I'm just hooking that together. Hook the other end back to the positive of the terminal again, and I'm going to read again. And you can see right now that we're down to 0.211. So 0.211 or 0.210. So what happened? Why did the flow rate go down? Let's have a little think about that. Well, what did you think? Why did the flow rate go down? Well, if you were like many others, maybe you thought, well, the only thing different between the first reading and the second reading was 2 of these extra wires in one big loop, just 2 extra wires. And they accounted for a difference of about 0.222 amps to about 2.210 amps. So we're down, I don't know, 12 milliamps. That seems kind of like a lot. Just for this. This is supposed to be a conductor. Well, my friends, that's because everything has resistance. Everything. Even the batteries have resistance. The bulbs have resistance. The meter has resistance. The wires have resistance. Everything has resistance. It could be a small amount of resistance, but it's still resistance. Now, real quick, if we had to make a lesson out of this today and say, what affects the resistance of any object? Really 2 main things. In a wire, it's length and it's area. So the longer a wire is, the more resistance it's going to have. And then the thicker the wire is, the less resistance it has. So if you think of it as length on top, area on bottom, then if your length gets bigger, your resistance gets bigger. We measure that in ohms. If your area gets bigger, that's on the bottom, and then you're increasing the denominator, and that means your resistance gets smaller. If you think of it like a water pipe, if it's a thin water pipe and you're trying to pump water through the pipe, then the water pipe, if it's really thin or narrow, it's going to resist the water flow more. If it's longer, it's going to resist the flow more. If you have a thicker pipe, that's going to let more water flow through the pipe. So if we wrap up today, guys, just to say resistance in ohms is a function of two things, length and area for a wire. There's also something called resistivity. We're not going to talk too much about that, but if you think of it just the two things, length and area in terms of how it affects resistance, I think you have a pretty good idea of what to do. And we'll follow up tomorrow with Ohm's law. But hope that's okay. I'll put a Google form together to see how you're doing on speed of electrons in a circuit and resistance. Resistance, anything that resists the flow of charge, like the bulb, like the wires, like the meter. All right, guys. Well, hopefully that's good for today. Tomorrow I'm going to tackle Ohm's law, the relationship between the pressure pusher voltage, the resistance that you've got in the circuit, and the amps for the flow of charge. Hope that's okay, guys. Once again, check the Google Doc for your meeting dates and times, and I'll be ready to get you that starting tomorrow morning with the first hour. If nobody has any questions, that's fine. I'll just continue on through. There's a couple extra videos on the Google Doc I'd like you to check out as those come along. And I did post worksheet 34.1, which is a kind of a culmination of all of the stuff we've been talking about over the last few days. So if you get a chance to do that, that would be great. Okay? Have a great Wednesday, guys, and we'll see you tomorrow morning.